Hello, welcome to Astronautics for Exploits. This is Dr. Anyashola Ogundele. Interstellar Space Voyage, humanity's audacious step to explore deep space. The focus points are as follows: Stellar System, Interstellar Space Voyage, Interstellar Space Voyage Concept, and Interstellar Propulsion System Concept. Interstellar Space Voyage, humanity's giant stride and sojourn through the interstellar space, the space between the stars, and also referred to as the region between the Sun's heliosphere and other stars' astrospheres, which was once a science fiction and academic endeavors, is gradually becoming a reality. The renewed interest in interplanetary space and advancement of the deep space uncrewed and crewed missions technologies is opening a new chapter of interstellar space voyage. Interstellar space voyage, a hypothetical crewed and uncrewed voyage from one star or stellar system. Stars that orbit each other and bound by the gravitational attraction, or from one planetary system to another, have received various purposes. Research findings show that a lot of scientific and economic benefits will be obtained once interstellar space voyage became a reality. Because stars are separated by large distances of about hundreds of thousands of astronomical units, in comparison to two planets in the solar system having a distance between them to be about 55 astronomical units, interplanetary space voyage will need to take place at a high rate of speed of light, with travel times taking at least decades, millennia, or even longer. Presently, the speed required to undergo interplanetary space voyage exceeded the space technologies available. But various spacecraft propulsion system strategies and proposals to achieve such a voyage have been hypothesized and proposed. Examples are nuclear propulsion, beam power propulsion, and speculative physics approach. Examples of proposed interstellar space voyage approaches are through the use of slow uncrewed probes, fast uncrewed probes, slow crewed missions, and fast crewed missions. Stellar system. A star system or stellar system is a small number of stars that orbit each other, bound by gravitational attraction. A large group of stars bound by gravitation is generally called a star cluster or galaxy. Unlike stellar systems, planetary systems include planets and similar bodies, such as comets. A star system of two stars is known as a binary star. If there are no tidal effects, no perturbation from other forces, and no transfer of mass from one star to the other, such a system is stable, and both stars will trace out an elliptical orbit around the very center of the system indefinitely. Sirius A with its wide draft companion, Sirius B taken by the Hubble Space Telescope, is shown in this picture. Example of binary system are Sirius, Procyon, and Cygnus X1. In a physical triple star system, each star orbits the center of mass of the system. Usually, two of the stars form a closed binary system, and the third orbits this pair at a distance much larger than that of the binary orbit. Illustration of two bright stars, Alpha Centauri and Beta Centauri, both binaries, and Proxima Centauri, is shown in this picture. Interstellar space voyage. Interstellar space is the space between the stars. It is the region between the solar system's sun's heliosphere and the astrospheres of other stars. Heliosphere is a fast bubble of plasma, a gas of charged particles that spouts out of the sun. This outflow is known as the solar wind. The bubble surrounds the sun and stretches beyond the planet. Infrared image from NASA Special Space Telescope is shown in this picture. The average distance between stars in the Milky Way galaxy is about 5 light years. Scientists define the beginning of interstellar space as the place where the sun's constant flow of material and magnetic field stop affecting its surroundings. This place is called the heliosphere. It marks the end of a region created by our sun, that is called the heliosphere. Illustration of interstellar medium and astrosphere is shown in this picture. Interstellar space voyage is the hypothetical travel of spacecraft from one star system, solitary star or planetary system to another. Interstellar travel is expected to prove much more difficult than interplanetary spaceflight due to the vast difference in the scale of the involved distances. Although the distance between any two planets in the solar system is less than 55 astronomical units, stars are typically separated by hundreds of thousands of astronomical units. Illustration of interstellar travel using magnetic fusion plasma engine is shown in this picture. Interstellar space voyage concepts. Various concepts of interstellar space voyage have been proposed. Examples are slow uncrewed probes, fast uncrewed probes, slow crewed missions, and fast crewed missions. Artistic representation of a spaceship for interstellar travel is shown in this picture. Slow uncrewed probes. Slow interstellar missions based on current and near future propulsion technologies are associated with trip times starting from about several decades to thousands of years. These missions consist of sending a robotic probe to a nearby star for exploration, similar to interplanetary probes like those used in the Voyager program. By taking along no crew, the cost and complexity of the mission is significantly reduced, as is the mass that needs to be accelerated. Although technology lifetime is still a significant issue next to obtaining a reasonable speed of travel. Daedalus spacecraft concept of uncrewed interstellar probe is shown in this picture. Fast uncrewed probes, nanoprobes, near light speed nano spacecraft might be possible within the near future built on existing microchip technology. With a newly developed nanoscale thruster, researchers at the University of Michigan are developing thrusters which use nanoparticles as propellant. As a near-term solution, small laser-propelled interstellar probes based on current CubeSat technology were proposed in the context of Project Dragonfly. Shape of two massive galaxies distorted due to gravity is shown in this picture. Slow crew missions. In crew missions, the duration of a slow interstellar journey presents a major obstacle, and the existing concepts deal with this problem in different ways. They can be distinguished by the state in which humans are transported on board of the spacecraft. It has been proposed that slow crew missions could be achieved by generation ships. Stanford Torus-based generation ship is shown in this picture. Fast crewed missions. If a spaceship could average 10% of light speed and decelerate at the destination for human crew missions, this would be enough to reach Proxima Centauri in 40 years. Several propulsion concepts have been proposed that might be eventually developed. Example propulsion concepts are time dilation and constant acceleration. Diagram of the early solar system protoplanetary disk is shown in this picture. Interstellar propulsion system concepts. All rocket concepts are limited by the rocket equation, which says the characteristic velocity available as a function of exhaust velocity and mass ratio, the ratio of initial to final mass. Various interstellar rocket concepts have been proposed, but the technologies are not yet well established. Artist's depiction of a hypothetical wormhole induction propelled spacecraft is shown in this picture. Interstellar propulsion system concepts are as follows: ion engine, nuclear fission powered nuclear fusion rockets, antimatter rockets, rockets with an external energy source, non-rocket concepts, interstellar ramjets, transmission of minds with light, and faster than light travel, wormholes, and a host of others. Modern post-fission propulsion concept is shown in this picture. Ion engine rocket concept. In an ion engine, electric power is used to create charged particles of the propellant, usually the gas xenon, and accelerate them to extremely high velocities. This is used in down space probe. Nuclear electric or plasma engines operating for long periods at low thrust and powered by fission reactors have the potential to reach speeds much greater than chemically powered vehicles or nuclear-themed rockets. Dawn space probe that orbited the protoplanet Vesta is shown in this picture. Fission fragment rocket concepts use nuclear fission to create high-speed jets of fission fragments, which are ejected at speeds of up to 12,000 km per second. Nuclear pulse interstellar rockets. Based on work in the late 1950s to the early 1960s, it has been technically possible to build spaceships with nuclear pulse propulsion engines, driven by a series of nuclear explosions. An artist's concept of the Project Orion basic spacecraft, powered by nuclear pulse propulsion, is shown in this picture. Nuclear fusion rocket concepts. Fusion rocket starships, powered by nuclear fusion reactions, should conceivably be able to reach speeds of the order of 10% of that of light, based on energy concentrations alone. Antimatter rockets interstellar rocket. An antimatter rocket is a proposed class of rockets that use antimatter as their power source. The advantage is that the light fraction of the rest mass of a matter antimatter mixture may be converted to energy. A proposed antimatter rocket is shown in this picture. Interstellar ramjet rocket concept. A fusion rocket in which a huge scoop will collect the diffuse hydrogen in interstellar space, burn it on the fly using a proton chain reaction and expel it out of the back. Transmission of minds with light concept. Uploaded human minds or artificial intelligence could be transmitted with laser or radio signals at the speed of light. This requires a receiver at the destination, which will first have to be set up, for example by humans, probes, self-replication machines, or an alien civilization. Artist's concept of a buzzard ramjet is shown in this picture. Faster than light travel rocket concept. Scientists and others have postulated several ways by which it might be possible to surpass the speed of light. Proposed mechanisms for faster than light travel within the theory of relativity require the existence of exotic matter. The wormholes concept. Uploaded human minds or AI could be transmitted with laser or radio signals at the speed of light. This requires a receiver at the destination, which will first have to be set up. A concept image of a spacecraft powered by a fusion-driven rocket is shown in this picture. For more information, contact Astronautics for Exploit. You've been listening to Interstellar Space Voyage, humanity's audacious step to explore this space, with the focus points stellar system, interstellar space voyage concepts, and interstellar propulsion system concepts, presented by Dr. Anishola Ogundele. Thank you.